Question 1A here, we've got a calculator, so we literally just type this into the calculator. If you can make it look like it does on the paper on your screen, then you will get the right answer. I'll show you how to type this in, and we should get this, and then that would be your answer. As simple as that. So just make sure you know how to use your calculator, it's really important. Reciprocal of a number, well, 0.625, if you put it into your calculator and push equals, it'll tell you it's 5/8. The reciprocal of a number, we use this when we divide fractions, we flip it over. So the reciprocal of 5/8 is 8/5, which is 1.6. Now we can't put the 8/5, we need to put the 1.6. The button on your calculator that will do this for you, if you type in 5/8 to the power of -1, that gives you the reciprocal, gives you 8/5. If you times a number by its reciprocal, it gives you 1. But we're probably most used to doing it where we flip the fraction over, and that's what that does. 60 is a product of prime factors. Now, without a calculator, we do the factor tree. I like to go with 2 each time. So the way this works, 2 times 30 is 60, 2 times 15 is 30, 3 times 5 is 15. So a couple of things here. I didn't really explain fully what I was doing, so I'll go back through it in a second. You can see that there's some stuff already written here. That's from my hint paper. So I'm starting to create hint papers for every GCSE past paper, so you might find them useful if you're struggling on a paper. But ultimately what I was doing here was thinking of 2 numbers that times to make 60, 2 times 30. Now I circled the 2 because it's prime, and again 2 times 15 is 30. Again I circled the 2 because it's prime, and then 3 times 5 is 15. Now you can actually do this on your calculator. You obviously need to know how to do it without a calculator, but you can just type in 60 and then push equals, and depending on your calculator, we either push format and take it down to prime factor, or on some of the older calculators, you need to push shift and fact at that point. But either way, we should get 2 times 2 times 3 times 5, or the perfect answer, 2 squared times 3 times 5. But either of those are fine. So that's the product of prime factors. Question 3, there are 48 counters in a bag, so have a read through this. You're probably here watching this if you're unsure of it. It kind of makes no sense to me, this question. I don't really get what Helen's on about. So what you can do in these questions is just say what the answer should be. So if we're sharing it in a 1:2 ratio, we would divide 48 by 3 and get 16. So there should be 16 red. And we need to make sure we answer this. No, she's not correct. She said there'd be 24. There would be 16. So if you're struggling to sort of look at someone else's working out and sort of say what they've done wrong, what you can always do is just say what they should have done. We've got to list the, we will not list the numbers. It looked like we were going to list all the numbers between -2 and 5. We're after the greatest possible value of n. Well, let's list the numbers anyway. N can be any number between -2 and 5, including -2. If n is an integer, that means a whole number. And that also means it can't be 5 because of the inequality symbol, n is less than 5. So the greatest possible value of n is 4. You didn't need to list them, but I like to do it like that. And on the number line, we're going to show this inequality. So when it's between 2 values, you draw a circle above them and we connect them. And then we need to consider whether we color it in. So this symbol means that n can be 4, so we're going to color it in. It can't be 1, it's less than 1, so we don't color it in. So that would be the answer for that. Solving an inequality, I've sort of started it off here. If 2/5 of g take away 4 is less than 6, well, let's get rid of the -4, so we add 4 to get 10. How do we get rid of the 2/5 here? Well, what we can do is times it by the reciprocal of 2/5, which is 5/2. Similar to what we were doing in question 1. So if we times 2/5 by 5/2, we get G. And then 10 times 5/2 is 25. So we get G is less than 25. What's really important here, I'm going to put that on the answer line. This wouldn't be right. We can't just put 25. G is less than 25. It needs the letter, it needs the inequality symbol. Otherwise, that would be considered incorrect. Because actually, G can't equal 25. It's any number less than 25. Again, we can see my sort of hints here. It's not a huge hint, but it's sort of just guiding you what to do. We need to figure out the area of the triangle and the area of the rectangle, and we're going to do this as expressions because we don't know the exact lengths. So the area of the triangle is half times base times height. So half times 6x times 8. I'm just going to use brackets for that. 6 times 8 is 48. Halved is 24, so we get 24x. The area of the rectangle is 5 times 4x minus 1, length times width. You can see some brackets have appeared here, single brackets, because we've got to times 5 by all of 4x minus 1. And we get 20x minus 5. Now we've got to figure out what x is, and we normally do that by forming an equation. Now we can't actually put these two equal to each other. Well, not yet. We can't just say this because they're not equal to each other. We're told that the area of the triangle is 10 centimeters greater than the area of the rectangle. So we've got a couple of choices here. We could take away 10 from the area of the triangle, or we can add 10 to the area of the rectangle, and that would make them equal to each other. So I'm just going to highlight that there. They are equal to each other if I add 10 onto the area of the rectangle. So now we've got a linear equation. We're just going to solve this. First thing I would probably do is add the minus 5 and the 10 together to get plus 5. Then we need to get all the x's on one side. There are more on the left, so we're going to take away the 20x from both sides to get 4x equals 5. And then to find out what x is, we divide 5 by 4. We're not allowed to leave it like that because it's improper. So we can say 1 1/4 and we can say 1.25. Now we can check whether 1.25 is correct by substituting back in up here. So 6 times 1.25 will be 7.5. Let's just check that. Yeah, 7.5 times 8 and then halved gives us an area of 30. And if we substitute in 1.25, 4 times 1.25 for the rectangle, take away 1 is 4, 5 times 4 is 20. So by substituting back in, I have shown that the area of the triangle is 10 centimeters squared bigger than the area of the rectangle. So I know I've done it correct. So I can feel confident that 1.25 is my answer. Question 6. Again, I've highlighted some things here to help me. We're told that 57% of the waste was paper and glass. So we can straight away just figure out what 57% of 800 is. It is 456 kilograms. Okay, and then this waste paper and glass was in a ratio of 12:7, which means 19 parts. 12 add 7 is 19 parts. And we can say those 19 parts are equal to 456 kilograms. So we can now figure out what one part is. One part is 456 divided by 19, which is 24. And then we need to calculate the weight of glass the family recycled. Well, glass was 7 parts. So to figure out 7 parts, we times 24 by 7. And that is a weight of 168 kilograms. Question 7, a very learnable topic, something we should hopefully start to feel happy to see. An error interval. So the idea behind this is if you round a number, it could be bigger than the number you're given or smaller. So the error interval is sort of showing you the possible values it could take. So if it's been rounded to 12.7, it could be as small as 12.65. That's the lower bound for the number. So it goes on this side. And it could be as big as 12.75. Between those two numbers, we would round to 12.7. Now, if it was 12.75, we would round it up to 12.8. But this symbol here is suggesting any number less than 12.75. So that takes into account that kind of inconsistency. So that's the error interval for 12.7. Question 8, we've got a question about house values and percentages. Tamsin buys a house with a value of 150,000. Her house increases by 4% each year. And then Rachel buys a house for more money, for 160,000, but her house increases by 1.5% each year. So we've got to figure out whose house has the greater value at the end of 2 years. So what we need to know, this is a compound interest question, because Tamsin's house is going to grow by 4%, and then that's going to grow by 4% again. So we need to know what the decimal multiplier for 4% is. Well, 100 plus 4 is 104%. To increase something by 104%, you times it by 1.04. So for this question, we're going to do 150,000 times 1.04 twice, because it's for 2 years. So we can write it like this, or we can write it as times 1.04 squared. So typing that into the calculator will give us how much hers is after 2 years. And it works out as £162,240. So it's now worth more than Rachel's was. But Rachel's we now need to put up by 1.5%. So 100% add 1.5% is 101.5%. As a decimal, we divide it by 100, but it's just 1.015. So to figure out Rachel's house, we're going to do 160,000 times 1.015. This time we'll just put the squared, rather than doing it as two separate multiplications. And when we do this, we get 164,836. And we need to remember to answer the question, whose house has the greater value? Rachel. Rachel's house is worth more because 164,000 is more than 162,000. So that's compound interest. If you're not sure of that, it's a good topic to go away and practice. Once you do enough of it, it's quite doable. Question 9, we've got a cumulative frequency graph. Now, these are always quite hard to show on screen. What we need to be aware of with a cumulative frequency graph, let's just talk about how we do it. We're going to plot it, the cumulative frequency of 20, at the top end of this group. So at the 30-year-olds. So the first group is 20 to 30-year-olds. This is about the ages of people working for a company. So we're going to plot on this graph, come over to here. It's already done. This is from my hint paper. It's showing you that the cumulative frequency of 20 is for someone with an age of 30, for the end of the group. So if we plot these on, the next group, 30 to 40-year-olds, that was 48. And the group after that, 40 to 50-year-olds, has a cumulative frequency of 64. And if we keep going on this, the next group had a cumulative frequency of 75. And then the final group took us up to the 80 people. Now, there's varying ideas on how you draw it. Some people are drawing straight lines. I like to join these up with a curve like this. The main thing is you don't miss any other points. So that's a cumulative frequency graph. I didn't really talk about why we'd do it. The idea behind this, when you have group data, we had a group table. we didn't know anyone's specific ages. So the idea of plotting a cumulative frequency graph is we can go within the groups and figure out what's going on. So we're being asked in part B to find an estimate for the median age. So the median is the person in the middle. If there's 80 people, the median will be the 40th person. So we're going to go to 40 in our cumulative frequency, not in our age. It's important we don't make that mistake. So we're coming to 40 in the cumulative frequency, which is here. And we're trying to figure out where they are within the group. They're in the 30 to 40-year-old group. And we can say they're probably about 37. So the median person we think is 37 years old. There'll be a bit of a range for this, depending on how you drew it. Anywhere from 36 to 38 would be fine. I got 37 when I did it. If you're not sure about cumulative frequency graphs, they can be worth a lot more than 3 marks. This one was only worth 3 marks. I've seen them be like 6 marks. It's worth getting good at this. It's worth trying to understand what they are, how you use them. They're not particularly hard, but people get confused between other similar topics, which tends to be the issue. Question 10 here, we've got a biased dice. So a biased dice means it's not landing on the numbers equally or fairly. And we've got a table that shows the information about the number that the dice lands on. So Geffen throws the dice twice. Work out an estimate for the probability that the dice will land on a 6 both times. So what we need to do here is we can say, right, well, it's landed on a 6 15 times out of the 60 rolls. So it's landing on a 6 a quarter of the time. Probability it'll do it twice, well, you just times the 2 outcomes together. So probability of it landing on a 6 is a quarter. Multiply that by the probability of it happening again, which would still be a quarter. So a quarter times a quarter is a 16th. So that's the probability this biased dice will land on a 6 both times. And Sally is going to throw the same dice n times, so we don't know how many times, and record the number it lands on each time. She'll use her results to work out a more reliable estimate for the probability in part A. What can we say about the value of n? So to make your results as good as possible, and particularly to be more reliable, we need n to be as big as possible. So n must be greater than 60 to get better results than these. The bigger n is, the better the results. But for this question, what we need to say is that n is greater than 60. Question 11, we've got some simultaneous equations. Not easy to get the hang of because they're constantly quite different to each other, but worth being good at because even if you get the question wrong, you can often pick up all the method marks, so get 2 out of 3 marks. We've got 2 choices here. I mean, I like to use elimination, which means we're either going to get the x's the same or the y's the same, and then either add the 2 equations or subtract them. I would always get, in this case, the y is the same. I think it's easier because y is positive in one equation and negative in another. And this way we can add them together once we get them the same. So I'm going to change both these numbers so that it's a common multiple of 6 and 4, which would be 24. So I'm going to change the top one to be 8x plus 24y equals 20. Now what I've done there is I've times everything by 4, so that I ended up with 24y. On the bottom one, I'm going to times everything. Oh, I'm going with 24. I could be going with 12. That's much simpler. So let's change that. I'm going to times the top one by 2. So there's 4x plus 12y equals 10. And the bottom one, I'm going to times it by 3. So I get 9x minus 12y equals minus 36. Now remember, use your calculator because you've got it. Don't be doing these in your head. And then we're going to add the 2 equations together now. That's going to eliminate the y's. So we get 13x equals minus 26. So to figure out x, we divide by 13. Minus 26 divided by 13 is minus 2. And then to figure out y, now that we know x, we can substitute back in. So 2 times minus 2 plus 6y equals 5. So we've got minus 4 plus 6y equals 5. Get 6y as the subject, so we add on 4 to get 9. And then finally, to figure out y, we divide our 9 by 6. So y is 1.5. So x equals minus 2, y equals 1.5. Question 12, we need to find the circumference of this circle. So we need to know the formula. The formula for the circumference of a circle is pi times the diameter. And if we look at the circle, we don't know the diameter. So the diameter is the length all the way across the middle going through the center. But we do know 2 other lengths within this circle. And you can kind of see a right angle triangle here. I've sort of drawn this on again. This is from my hint paper. So maybe if you're doing this and you're unsure, maybe this would have helped you. So we've got a right angle triangle where we know 2 sides. And if we want to figure out the third side, we're going to use Pythagoras. So a squared plus b squared equals c squared. And c is the hypotenuse, which is what we're trying to find. That is also the diameter of this circle. So 8 squared plus 10 squared is equal to c squared. So c squared is 164. So c will be the square root of 164. So c in this case, not to be confused with the circumference, this is the diameter. So we are now going to do pi times the square root of 164, and that will give us the circumference. So I'm just going to type that into my calculator, and I get 40.2 centimeters. Question 13. So we've got a non-right angle triangle here. So we should be thinking sine rule or cosine rule. Sort of highlighted some things on here, and it is the sine rule for this question. So we're being asked to find angle BAC. Now we can get that. What we need to do is figure out a couple of things first, which is, in fact, we're going to figure out the blue angle. So if I call that, say, X, we're going to use that to figure out the red angle, because once we know the blue and the yellow angle, we can figure out the third missing angle. The reason we're going to figure out the blue angle is we know the side opposite it, and we know this side and this angle. So you always need to know a side and an angle opposite to use the sine rule. So substituting in here, we can say sine 70 over 18, so the sine of the angle divided by the side opposite is equal to sine x divided by 15. So that relationship will always hold true. And we're going to rearrange this to figure out what x is. So we can say the sine of x, to get rid of that divide by 15, we times by 15. So 15 times sine 70 over 18. And then to figure out what x is, we need to use the inverse function. So the sine to the minus 1 of whatever that answer is. I'm just going to type it into the calculator, and I get x as 51.5. Now that we know that, and that is the blue angle, so let's just highlight that in blue. So we now know one angle is 51.5. We've also got that 70-degree angle we knew, and we can now figure out what angle BAC is by adding the 2 we know together and taking it away from 180. And we get 58.5. Question 14. Again, there's some hints here. when we're being asked to simplify these quadratic fractions, so a fraction with a quadratic expression on top and bottom, what we need to be looking to do is factorize the top, factorize the bottom, and then we're going to get the same bracket on top as we get on bottom, and we're going to cross them out. So we're going to do that in a minute. So we should always look to factorize the easier one. It's easier to factorize the top because the coefficient of x squared, the number in front of x squared, is just 1. It's a hidden 1, but it's there. For the one underneath, we got a 2, which makes it a bit harder to factorize. So if we do the one on top, what we should be thinking, and this is really important to be good at on the higher paper, what are the factors of 6? What two numbers will times to make 6? There's only 2 choices, and these are the numbers that are going to go into the bracket on top. And I know it's going to be 3 and 2 because these 2 numbers add to give us -1 here. And we can get that from -3x and +2x, which is what we'll get when we expand the top bracket. Now I know straight away now that I can put a -3 here because on the bottom we've got a 3 here, and that can only be made by multiplying 3 and 1. So I know x plus 2 can't appear on the bottom. And that's got to be a +1 to multiply to make -3. So when we cross these 2 out, we get x plus 2 over 2x plus 1. So these are algebraic fractions. There's loads of questions like that on my website. If you want some more like that, just follow the links in the description. And then question 15, we've got a quadratic sequence. There's a few ways of doing this. I like to use the method where this is 2a, this is 3a plus b, and this is a plus b plus c. Now, what do I mean by a, b, and c? Well, any quadratic sequence will be in the form an squared plus bn plus c. Now, if you learn these 3 little expressions, I suppose, that we can put equal to the numbers here, we can figure out what a, b, and c are. So for this one, 2a equals 2, so a equals 1. So it's going to be 1n squared. We don't need the 1 there, but we can put it. We now know that a is 1. So here, instead of writing 3a plus b equals 6, what we can say is 3 times 1, which is 3, plus b equals 6. So b must be 3, and positive 3, so we can put plus 3n here. Then last of all, we go to the top where we've got a plus b plus c equals 3. Well, we know a is 1 and b is 3, so when we add them together, we get 4. So 4 plus c equals 3. That means that c must be negative. It must be whatever 3 take away 4 is, so -1. And that goes there. So that is our nth term of the quadratic sequence. That's the rule for the sequence. It would allow us to figure out any term in the sequence we wanted to. Now, before we move on here, we should be thinking, are we correct? So I'm going to pick this term, which is the 3rd term. Here, n is 3. Now, if I substitute into my nth term, so 3 squared plus 3 times 3, take away 1, I should get 17. If I don't get 17, I've gone wrong. 9 plus 9 is 18, take away 1 does equal 17. So I know I've got the correct answer. If this is my real GCSE, I might substitute in 2 as well and see if I get 9. Just to be 100% clear, I got this right, so I know when moving on I've got all 3 marks. Really learnable this. There's a few other methods for doing this. This is my favourite way of doing it. Again, I've got lots of questions like this on my website if you want to practice that method. There's lots of videos explaining how to do that method on different websites as well. And question 16, we've got histograms. So histogram is kind of like a bar chart, but it's not a bar chart. The bars are touching, which is not allowed with bar charts, and also we've got unequal widths, which is not allowed with bar charts. So that's the difference between a histogram and a bar chart. And a histogram, the height of the bar is the frequency density, and the frequency density is the frequency divided by the class width. So it's the area of each bar that represents how many people are in it. So the frequency density is the frequency divided by the class width. And we are told that 28 students use their phones for between 30 and 40 hours. So this I've highlighted in blue, and the blue bar represents that many people. So what would we do here to figure out the frequency density? Well, we would divide 28, which is the number of students, by 10, because they're using their phones between 30 and 40 hours, which is a class width of 10. So that gives us a frequency density of 2.8, which is what this number here must be, because that's where the height of the bar is. So we can now figure out the scale. This would be 1, this would be 2, and this here would be 3. With each little square as we go up being 0.1, so 2.5 here. So now that we know the scale, we can use this information to complete the histogram. We're going to draw the bar for the final group of students that use their phone between 40 and 60 hours. So what we would do is divide the frequency 24 by 20, because 40 to 60 hours is a width of 20 hours. And 24 divided by 20 is going to be 1.2. So we need to come up to 1.2, which is here, and come across until we hit 60 hours. So that bar represents students that use their phone between 40 and 60 hours. So that's the histogram completed. No student used their phone for more than 60 hours. Work out the total number of students. What's important to remember, we knew this was 24. So we need to figure out how many students are in each bar. So this bar, to figure out how many students this is, we figure out the area of the bar. So it's got a length of 20, that goes from 0 to 20 hours, and a height of 1.6. So 20 times 1.6, there's 32 students there. And then to figure out this last bar, again, we're going to do the width, which is 10, because it runs from 20 to 30 hours. 10 times a height of 3.6. And 10 times 3.6 is 36. So the total number of students, we're going to add together these numbers, 32, 36, 28, and 24. And when we add these together, we get 120, which feels like the right answer. Question 17 is an iteration question. And the first part here, it wants us to rearrange this equation so that it's in the form x equals the fourth root of x squared plus 5. So what we need to do here, starting with the equation we're given, is you might spot that we're going to take the x squared and the minus 5 across. So they become x squared plus 5. And then if we fourth root everything, we've got x kind of as the subject. X is on the other side, so it's not technically the subject, but we've got an iteration formula now, which we're going to use in part B. So part B, once you've done enough of these, once you get used to the notation, these are quite easy. All we're going to do is we start off with x subscript 0 equaling 1.5. That's just the first number we're going to put in. So we're going to put that number into our formula as I'm typing in on the screen. And when we put that 1.5 in, we get 1.6409. Now we're going to put that number in to find the next value of x. We're going to put it in again. So you can use the answer button on your calculator just to quickly do this. And we do it again, and we get 1.6653. And then we put that in again. Just going to write some of it. The third time we put it in, we get our solution. And that is 1.6697. Okay, and it hasn't asked us how to round it, so 4 decimal places is always good enough. So let's leave it like that. Question 18, we're going to combine these ratios. We've got 2a to 5c is equal to 6 to 25. If we divide the 2a by 2, we get a, so we would divide the 6 by 2 to get 3. And likewise, if we make 5c just c, we need to divide it by 5. So we divide the 25 by 5. If we do the same with the 4b to 7c, we're going to divide 20 by 4 because we've got 4 b's, and we're going to divide 21 by 7 because we've got 7 c's. So now we've simplified these ratios. If we combine them to a to b to c, a to c is 3 to 5, and b to c is 5 to 3. And now what we want to do is to combine these ratios, we need a common multiple of 5 and 3, which would be 15. We get that by timesing the 5 by 3. So we would also times this 3 by 3. It becomes 9. And we would times this 3 by 5 to make it 15. So we times the 5 by 5 to get 25. So now it's in the ratio 9 to 25 to 15. A plus B is 9 plus 25, which is 31. And B plus C is, that's 31, 34. And B plus C is 25 add 15, which is 40. So then we can say they're in the ratio 34 to 40, and we can halve those to get 17 to 20, which is what it wanted us to show. So that's a difficult combining ratios question. Question 19, we've got a right angle triangle. So this question is a combination of trigonometry, which hopefully you're all good at, and bounds. So bounds is the concept where when we round numbers, they could be slightly bigger and they could be slightly smaller than the number we're using because we rounded them. So I would always start off here by figuring out the lower and upper bound for each number. So the lower bound for 9.3, it could be as small as 9.25 or as big as 9.35. 12.6 could be as small as 12.55 or as big as 12.65. If these are seen, you'll get a mark. So if we start off by doing this, we've got a mark. Next step here, we need to be thinking trigonometry. So the angle we know is x. So 9.3 is opposite the angle we know. And 12.6 is the hypotenuse. So what we need to be thinking here is that we are using sine, which is the opposite divided by the hypotenuse. And to get, we're after the lower bound for the angle here. So that doesn't necessarily mean we used 9.25 and 12.5 in the question. To make the angle as small as possible, we are going to use 9.25 for the opposite. But if the hypotenuse is as long as possible, that will make the angle as small as possible. So we're going to use the 12.65. So to figure out the angle here, we're going to use the inverse function. And we're going to type all this into the calculator and find out what the angle is. And we should get 46.989. And I would be tempted just to say 47.0 degrees. We're going to 1 decimal place because the question, all the numbers have been rounded to 1 decimal place. Question 20, we've got a vector proof question here. This isn't too bad. These can be really tricky. Always good to start off by just finding a few vectors. So on my hint paper, I suggested maybe you find O to R. O to R can be found by going O to T and then T to R. So we'll probably get a mark just for doing this. So O to T is A and T to R is minus B. So going from O to R is A minus B. And then I'd be tempted to find things like O to M or M to R. We need to use the ratio here. So we're told the ratio of O to M to R is 2 to 3. So this is 2/5 of the way along O to R, and this is 3/5 of the way along. So O to M will be 2/5 of that A minus B, and M to R would be 3/5 of it. So we're going to use one of these because we're being asked to find M to T, which is, let's pick a nice color for this, maybe a purple. M to T, which is this. So we can either go M to R and then R to T, or M to O and then O to T. I'm going to go M to R and then R to T. So M to R is 3/5 of A minus 3/5 of B if we expand the bracket. So let's get the purple up again. M to T is M to R plus R to T. So it's 3/5 A minus 3/5 of B plus B, because R to T is B. So to finish this off, we just need to tidy it up. 3/5 of A stays 3/5 of A. And then we got minus 3/5 of B plus B. Well, we can think of that as 5/5 of B. So overall, we get 2/5 of B. So that is the vector M to T in terms of A and B in its simplest form. I say that's not too bad. This is a topic, can be one of the hardest topics on the paper. Loads more questions like that on my website if you want to practice that topic. Question 21 here, we've got a transformation of graphs. So we just need to get used to what to do here. These aren't too bad. On the grid, draw the graph y equals f of x minus 4. So the minus 4 is outside the bracket. So that means all the coordinates are going to be affected in the y value. And when it affects the y value, you do what it says. So they're all going down 4. So every point is going to go down 4. This one's going to go down 4 as well. This point was here, down 4 to there. You can probably see where the final one's going. Okay, so it moves to like that. I might just redraw that last line like that. And then the second one. Okay. Oh, I should have drawn it on the second graph. Okay, that's strange. So actually where I should have drawn it is down here. Not on the original graph. And then B, on the graph, draw y equals function minus x. So this is going to affect the x values. Whatever happens inside the bracket affects the x values, and they're all going to become negative. So it's going to flip in the y-axis over here. It was originally like this. So this value, where x was minus 1, becomes positive 1. This value where x is minus 2 becomes positive 2. Question 22, this is quite a tricky one. We're basically told the probability of a red is 1/5 because there are 4 times as many blues as reds. So therefore the probability of a blue is 4/5. Overall, we're being asked to find the probability, to write an expression for the probability that Rita gets a blue pen at least once and a red pen at least once. Now that's quite tricky. The way we need to think about this is, what's the probability that all the pens are red? So we're going to work that out. We're also going to work out the probability that all the pens are blue. So whatever we get for those, what it's asking us, the probability that Rita gets a blue pen at least once and a red pen at least once, will be 1. Take away whatever the probability of them all being red is. And we're also going to take away the probability that they're all blue. So we will find what they're asking for by subtracting the two probabilities that don't fulfill it, which is all red or all blue. So what's the probability every pen is red? Well, if we were picking red pens and we did it 3 times, the probability of getting a red 3 times in a row would be 1/5 to the power of 3. If we were doing it 7 times in a row, it would be 1/5 to the power of 7. But because we're doing it n times, the probability of every pen being red is 1/5 to the power of n, because n would be how many times we do it. So that can go there. Once you spot this, this is now quite easy. Well, the probability that they're all blue is now 4/5 to the power of n. So that's what we can put here. So we've answered this question by subtracting the two probabilities that don't fulfill what it's asking. So what we're left with is the probability we'll get a blue pen at least once and a red pen at least once. Okay, question 23 is a similar shapes question. It also involves area. So I've drawn these 3 triangles, these 3 similar triangles separately. And I know that the lengths are in the ratio 1 to 3 to 6. So that's based on this 1, this 3, and this 6. The area, we can then get the ratio of the areas of the triangles. What we would do is square these numbers. We would square the 1 to get 1, square the 3 to get 9, and square the 6 to get 36. So that's the area of the triangles in relation to each other. That's the ratio of their areas. Now we're being asked to show that area of ABG, which is the small triangle. So ABG is 1. So the area of BCFG. Now BCFG is this trapezium. And the trapezium is the area of AFC, which we've got as 9, take away this area, to take away that area off the top. So it's going to be 9 take away 1, which is 8. So BCFG, ratio of its area would be 8 to this. And we're now going to do the same for CDEFG, which is the big triangle down here. Let's use a different color. It's this triangle. Let's make that a bit thicker. So it's this triangle missing triangle AFC. So taking away that AFC. So it's going to be 36, take away 9, which is 27. This would be 9 here. Overall, this was 36. So if we take away the 9, we get 27, because that is the trapezium CDEFG. This one down here. So 27 to 8 to 1. So not only did we need to know the ratio of their areas, we needed to know how to apply it to these shapes. Question 24, this is the final question on the paper, and it's quite tricky. You can see here from my hint paper, I'm kind of thinking of this shaded area being the area of this big square plus the area of these 4 triangles added together. So the area of the triangles is actually quite an easy place to start. To get the area of the triangle, because they're right angle triangles, base times height is a times a, which is a squared. And it's just half of that. So the area of each triangle is half a squared. There's 4 of them. So the area of 4 triangles, we're going to times that by 4. But we'll do that later on. To work out the area of the square, we need to work out the length of what I've called B. So these green edges. If we go back to this little triangle, we can use Pythagoras to get that, because B squared will be equal to A squared plus A squared. So B squared is equal to 2A squared. So B is the square root of 2A squared. Okay, so we now know B. So in terms of our square, this big square, we now know that the sides are, we've got this A, and we've got this root 2a squared. So adding these together will give us the sides. So that side is 2a plus root 2a squared. So to get the area of the square, we would do length times width. They're the same things. So we're going to do 2a plus root 2a squared and times it by itself. So to do that, I'm going to come down here to do it. So I got my length of the square as this. I think it probably makes sense to actually adjust this to 2a plus root 2 lots of a, because then I can take a out as a factor. So now to get the area of the square, I'm going to do a brackets 2 plus root 2, and I'm going to square all of that. So in doing that, I get a squared. And if I expand 2 plus root 2 down here, 2 times 2 is 4, plus 2 root 2, plus another 2 root 2, and root 2 times root 2 is 2. So overall that becomes 6 plus 4 lots of root 2. So I'm going to put that there. Now we said the area of the triangles, each triangle was half of a squared, and there's 4 of them. So we now end up with 2a squared. So obviously I wouldn't get rid of my working out down here in the exam, but I'm going to. And then the overall area of the square and the triangles would be a squared 6 plus 4 root 2 plus another 2a squared. So what we can do there is take that 2 inside the bracket and say overall we've got a squared 8 plus 4 root 2 as our area. And let me just check I did that. And I could, looking at the answer, there's a p on the outside as well. So there's a number that can come out. So 4 is a factor of both. So 4 lots of 2 plus root 2 a squared would be my overall answer. So it's always worth looking back at how they asked us to write it. They were very clear up here. So I would have left the 4 maybe in the brackets, but they wanted that to come out. So that's the final question. Thank you.